Okay, if you look at the lab this week, you have two documents that you need to download. The first document is the procedure, and the second document is graphs. You are given actually the graph templates. You don't need to graph from scratch. I gave you already the templates, and you just need to fill in the data. Okay, just to save time here. But make sure here when you look at the graph, you'll see two sheets. So make sure to enable it first. And you can see here down there, you have sheet number 1 and sheet number 2. So first you click on sheet number 1 where you'll input the values of the voltage versus current. You'll be actually doing an experiment. You'll be setting the resistance constant in the first table. And you'll be changing the value of the voltage from 1.5 to 3 volts, 4.5, 6 volts, and so on. And you'll be recording the corresponding current for each voltage. So record the values here, and you'll see actually the graph will be plotted on its own. Okay. So for example, if I put some values here, let me put here 3, let me put here 6, 9. You can see the graph is being plotted as I input those values, right? And then it will give me the slope of the graph. And the slope, of course, we know that the slope will represent the resistance. Why? Because if you remember the equation of straight line, in the case of straight line, y equal to the slope times the x-axis plus the y-intercept. So here, the equation of this graph is the voltage equal resistance times current plus 0. So if you take the voltage to be the y-axis, the voltage here is the y-axis, as you see. The voltage is the vertical axis, so it's the y-axis. And the electric current is the x-axis. So the resistance will be the slope. And the y-intercept should be 0. So that's why the slope here will be whatever the resistance is. Okay, so that's sheet number 1. Sheet number 2, you have to plot a graph of resistance versus current. So the first graph here was voltage versus current. The second one here, if you click on sheet number 2, is current versus resistance. So you record the values of the resistance here and then the corresponding current values. Now, what do you expect to get here? Current and resistance, are they directly proportional or inversely proportional? I'll let you figure it out actually when you do the experiment. So that's regarding to the graph. The procedure part tells you to go over several things. The first question in the procedure, it asks you to look at this simulation and try to construct a circuit using this simulation. You have a battery here that you can bring, and then you can connect the wires to create electric circuits. So this is, you need voltage source, you need wires. This is the wire here. So you can put wires and try to complete a circuit. Now notice here there is no electricity yet because the circuit is open. You can use a light bulb here, connected, and then try to complete the circuit. And you can use a switch. This is a switch here. You connect it. Now, of course, you can see here the switch is closed, which is turned off. So nothing will work when the switch is off. Now, when you close the switch, it will turn on. This is basically how we turn on and turn off a switch. Okay, you can create electricity. And notice here, if the voltage, for example, 9 volts, you get certain amount of electricity as demonstrated by the light. Notice here when the voltage is 9 volts, the current here is 0.9 amps. Now, if we increase the voltage, so let me set here the voltage from 9 volts, let me take it to maybe 90 volts. So you can see here I set it at 90 volts, so I increase the voltage. The electric current increased 10 times as well. From 9 to 90, that's 10 times increase in the voltage will increase the current 10 times. You can see the current is getting bigger here from the fact that the charges are moving faster. Remember, the definition of current is the amount of charge going through any point in the circuit per time. So now the amount of charge going through any point in the circuit per time is bigger. Also, we can increase the resistance. So here, if we click on the resistance, we can increase it to, let's say, from 10 ohms to 90 ohms. So you can see here, when I increase the resistance, the current has decreased because current and resistance are inversely proportional. And you can create series connection, if you will, or parallel connection. For example, if you connect another wire here, you can create another circuit with parallel connection. So those two light bulbs, they're not connected yet. You can see here, this is open circuit. So the circuit will continue working for this branch, but it's not working for the second branch. Now, if you connected, you can see both of them are working. And of course, this one has more resistance than this one. This one is almost 100 ohms, while the lower one is 10 ohms. So you have more electric current going through that one here. Okay, so you can play with this one here, but the main simulation that you'll be playing with, this one here, that's the second simulation. You're asked to set the resistance at 1000 ohms. So you'll take it up all the way to 1000 ohms. Yeah, 1000 ohms. And you're asked to set the voltage at 1.5, then 3, then 4.5, and so on. And each time you record the electric current that is pertinent to that voltage. So you set it at 1.5, you record the current, then you set it up to 3 volts and record the current and so on. This will be the first table in the procedure where resistance is set constant and the voltage and the current are the variables. The voltage is the independent variable that you manipulate as a conductor of the experiment, and the current will be the dependent variable. Okay, so that's on the first part. On the second part of the lab, the table, second table, we are going to set the voltage constant. So you'll set the voltage at 2 volts, and we are going to vary the resistance and monitor its effect on the current. So you'll set the resistance at 100 and try to get it as close as possible to 100. If you not get it exactly 100, that's fine. If you get it 99, that's fine. Okay, the same thing when you set it at 200, 300, and so on. You try your best to get it there. If you not get it there, that's fine. Okay. But you'll be able to see the relationship between voltage and current in the first table, and then in the second table, the relationship between resistance and current. And you'll be plotting the two graphs, one of them for voltage versus current, and the second table for resistance versus current. So make sure you save the graph, the two graphs, which will be one document. You'll save that document and then upload it in the question that asks you to upload it. And the rest of the questions are multiple choice. And there is, of course, the essay questions about what did you learn from playing with the simulation, that first simulation. Make sure you dedicate the time needed to complete this lab. All right, guess that's it.